Good morning. This is Tim Stewart. I am president at Visual Decisions, and we are here today to talk about how to create real-time value stream maps with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements such as 30% increases in OEE, 50% scrap reductions, and much more. As a quick procedural note, if you have questions during the presentation, please enter them into the Q&A. I will get to them at the end of the webinar. Thank you. So the goal for today is this: how can we make value stream mapping easier to perform, more accurate, more comprehensive, with more context, and perhaps most importantly, an evergreen, ongoing part of the daily management process instead of something that just hangs on the wall. So to get started, we'll take a look at the traditional mapping process. We'll also quickly review the typical mapping process output. So let's start with a basic question. Why do we do value stream mapping in the first place? The purpose of value stream mapping is to identify and remove or reduce waste in value streams, thereby increasing the efficiency of a given value stream. Waste removal is intended to increase productivity by creating leaner operations, which in turn make waste and quality problems easier to identify. Value stream mapping accomplishes these goals by allowing the team to see the big picture of how materials and information flow through the manufacturing process. This visualization allows them to identify areas of waste, select priorities, and allocate resources to optimize the flow. In addition, the mapping process helps the team generate ideas on what the next future state of the process looks like, as well as the ideal future state. So next, let's take a look at the overall mapping process. The process usually begins with a kickoff workshop. In this workshop, we define the scope, what value stream will be the focus of the exercise. Is it for a single product, a product family, something else? Do we need to do a product family analysis initially to figure out which products we can group together for the analysis? The other typical steps in a kickoff involve determining who needs to be involved in the workshop, creating the plan for the exercise, and how it's going to be completed. Other steps may be some initial charting, such as a brown paper chart that gives a very rough, high-level flow of materials through the manufacturing process. The next step in our typical mapping process is basic mapping. In this step, we create the basics of some of the fundamental mapping outputs, such as the actual value stream map, the quality filter maps, spaghetti diagrams, etc. And at this point, we may just outline our initial ideas of the flow, where quality issues are happening, etc. Once we have the mapping basics completed, then we need to collect data about the current state to add to the maps. While this can be accomplished in several different ways, the traditional path is to get out to the floor and view the process. This could mean talking to the operators and supervisors to get their input on takt time and performance information, or it could mean monitoring the process for collecting actuals for a while to get the data. It's also fairly common to perform a manufacturing audit at this point. Some examples for the criteria for the audit are Schoenberger's 16 Principles of World-Class Manufacturing, Kobayashi's 20 Keys, etc. After the data has been collected, it's time for the current state workshop. This is where the team reassembles to add data to the charts created back in the basic mapping step. At this point, the team will look at the completed visualizations to identify where there's waste in the process. And then the next step is to perform the detailed mapping. This could be done either during the current state workshop with the entire team, or the team may break into subgroups to create the necessary analyses. We'll have more detail on this step in the next slide. But once the overall analysis of the current state is completed, it's time to do the future state workshop. And during this workshop, the team will gather again to go through the analysis of the current state, brainstorm ideas, document the planned improvements, and create the action plan for improvement. There are two possible future states that the team may produce. There should always be a next future state map where the immediate goals are documented. And then optionally, the team may produce an ideal future state where all possible waste is removed. And either way, the team should create a detailed project plan for executing the improvements to get to that next future state. And then the final step is to make it so and implement the proposed changes. So while the value stream map itself is a key part of the process, there are many other outputs from a complete mapping project. And the list on this page is by no means meant to be comprehensive, despite the tiny little font there. Sorry for that. But this is, just a view of some of the most common outputs of the process. And I don't want to go through the details of all of them, but just a quick list, since the font is so small. Product family analysis. This generally looks to group individual products into families based on identifying commonalities in their manufacturing process. Overall lead time mapping. This can be viewed as a Gantt chart or as a Pareto and looks to quantify the total lead time. This can also cover information flows, material flows, manufacturing, service, et cetera. Anything that's considered to be part of the lead time for that product. Brown paper overview. This is very high level flow chart of the overall flow within the factory. Supply chain structure is a high level analysis of the various suppliers in the process. Seeing the whole from a supply chain is very similar to the value stream map within a plant, but views the overall intercompany supply chain map instead. The demand amplification map looks at how much batching and inventory control policies in the plant and overall supply chain lead to lumpy demand profiles that resist level loading within the plant. The cost time profile is showing the accumulated cost against time. Then the value stream map itself is traditional value stream map pictured on the left side there. Spaghetti diagram is a map of movement within the facility. It's used to identify waste for transport and motion. Quality filter map tracks the rates and sources of defects during the process, et cetera. So there's a lot of different potential outputs that you have from this process, in addition to just the traditional value stream map. So that was a very quick overview of the typical traditional mapping process and its outputs. As can be seen, it's a highly involved process that incorporates efforts from a lot of different people. And while it has tremendous value to the organization and is a critical part of any lean implementation, the traditional approach is actually very wasteful. Most of the data that is collected in the process of going out to the floor and collecting information by hand and so forth actually generally already exists in different systems and is available for use. So why gather the data manually? We'll take a look at the pros and cons of that manual approach and the digital approach in the next section. So why continue the traditional approach? And what are the primary advantages? And the things that I hear the most when I talk to lean professionals, first of all, is the involvement. And one of the biggest things is just having the people in the process, putting those sticky notes up there and so forth, gets them to participate in that, drives the ownership, drives the understanding of the entire process and so forth, and also just gets them invested in the change that you're going to be trying to make later on. And so, the thought process is that by doing all of this manually, by getting the people to actually, get in the room and interact with each other, you have, that wisdom of the teams, you have, the interaction and so forth that's, building the teamwork between the different people, and that you would lose that if you automated a lot of that data collection process. And so for, a lot of companies, this is a major part of the value stream mapping process, is the benefits that you get for the team itself from going through the process. in contrast, what are the benefits of going digital? And so there's a fairly strong argument to remain manual. So what then are the benefits of going digital, and why look at this in the first place? And primarily it revolves around accuracy, breadth, speed, and ongoing benefits. The focus shifts from collecting data to making improvements. So instead of creating something that hangs on the wall, it becomes a tool that people use on an ongoing daily basis. So let's go through the benefits of digital in a bit more detail. First of all, you can do pretty much all product families at one time. So when you're doing this manually, the reason that you focus on a single product family is that you have to narrow the scope. It's not possible to gather data on all the different products at once. You can't be everywhere in the facility at one time. And so the focus generally gets brought down to a single product family and focused within there. When the mapping is done digitally, the system is connected to the data sources that contain the raw data. And those systems have the data for all of the products. So instead of being forced to select a single family for the analysis and then going out to collect the data, you have the data for all the products at the beginning. If you want to run the analysis for a single product line at a time, that choice is still available, but now it's a choice instead of the only option. Both more precise and more accurate. So the information coming from the systems that gather data 24/7 is going to be far more precise and accurate than information gathered by hand. I can't emphasize this one enough. To begin with, the data that is typically gathered by hand is almost always biased. If someone is standing next to the line and watching the process collecting data, people simply behave differently. It's like when you're driving down the highway and see a policeman on the side of the road. Most people that see that officer watching will slow down and drive by the rules. People just behave differently when they're being watched. It's called the Hawthorne effect and has been studied extensively in psychology. So because of this, when you're standing by the line collecting data, the operators will behave differently than normal. It's human nature. So you're collecting biased data when you stand there watching the process. When the data is collected 24 hours a day, 7 days a week, it's unbiased because that's just the way the process always works by definition. So the data is far more accurate when you capture everything in detail. You capture all the common events, you capture the rare events, you capture the things that happen quickly that go unnoticed or unrecorded in manual data collection. And furthermore, you capture much more context with the systems than with the tick sheet. You know what products were being run, you know who the operator was at the time, what were the failure codes from the PLC, and much, much more. So you also capture process deviations this way. In the manual process, usually what gets recorded is the way that things are, the way that things happen most of the time. And what we capture in our value streams, when we're looking at that, we document the way that things normally flow. But when we're doing this automatically, we can actually see how things happen all the time. So not just the normal flow, but what are the deviations, the rework loops, the other paths that we take when machines are down, everything. And so being able to see not just one view of the process, but how it actually happens in all cases can be very valuable. In addition to capturing the data and representing it in a biased fashion, we also typically collect just a single number. What is the average for that process when we do things by hand? When we're collecting it automatically, we can look at not just what that average is, but what is the full range, what is the distribution of different times and so forth. And so what that helps us to do is to understand not only where we have problems on average, but also what are those extremes that we see within there, and how do those potentially stack up to create problems for us within our lines and value streams and so forth. And so that can be very valuable itself. And then it automatically updates with the process. And so, over time, value stream maps tend to get very stale because as changes are made to the process, very few times do we go back and actually update the value stream map of that process. And so the value stream map that's on the wall or in a drawer someplace typically becomes out of date relatively quickly and doesn't actually mirror what the actual process is any longer, let alone any new products or anything else that come out. And so with the digital approach, because we're connecting to those data sources that are collecting that data 24/7, whenever the process itself changes, the map is automatically updated. Another part of this is that it can be part of the daily process. Because the value stream map contains information about how long processes are supposed to take and how long materials are supposed to take between processes, it can be used as a tool to identify when things go off track. So as manufacturing is being monitored on an ongoing basis, the results can be compared to the value stream map, and alerts can go out to people responsible when the process is not performing as expected. When deviations from the standard process, for example, with rework take place, those deviations can also be noted and highlighted. So the maps can be used as part of the daily communication process. As an example, a live map can be used during shift handoff meetings to highlight recent deviations. The maps can be used as part of Kaizen projects to measure the impact of those improvements. Using the maps in this manner create the kind of deep understanding of the process in a much broader audience than is possible during a traditional mapping process itself. And because this is a document that lives on and becomes part of that daily workflow, you actually get more involvement and more ownership of it than you do from just a standalone project. Also, just as you're going through the project itself, the focus shifts to making the improvements. And so when you have the data collection happening automatically, you can still get, people to go out there and verify it and so forth. But, the focus really shifts to, okay, we understand the process itself now, but how do we make the process better? And really shifting the entire focus, or the vast majority of the focus, to, what are we going to do from here, rather than just documenting what is the current state, really helps people, have that ownership of the improvement process as opposed to just the documentation process. So with all of that said, we've established that there are many advantages to a digital mapping process. So how do we actually go digital? And the first thing to realize is that vast quantities of data originate at every step of the value chain. This is an image that we looked at with a bakery company. We looked at everything within the four walls of the plant, starting at receiving and going all the way out to shipping. And at every step along the process, they were already collecting information. There were PLCs that collected detailed information about each step in the process. Higher level work order information was being tracked in their MES system. Quality information was available in SPC systems and more. Without doing a complete inventory, there was a lot of data to tap in when we began the mapping process. And so I'm sure that within your operations, there's already a lot of data out there. And the key thing is, without even implementing any new systems, how can you tap into the data that's already out there and utilize that more effectively within your mapping process? So in general, where to get the data, again, it's pretty much everywhere once you start looking for it, but it does vary a little bit with each customer. Different companies have different systems implemented in different ways and may have different goals for the mapping process. But there are a number of standard systems where we look for the data, and the list is not meant to be comprehensive. But these are the common places where we start looking for the data that we can use in the process. Some of the data, for suppliers and things like that, will be within the ERP system. MES, depending on how you've implemented it, may track, each step within your process, and you might have, very good information within there. to be able to pull out how long does each step take, as well as how long are work orders spending in between steps and so forth. Planning systems can give you some of this context as well for how long things are supposed to take versus how long they're actually taking. Supply chain systems, certainly if you have an IoT or industrial Internet of Things system implemented on the shop floor, that will have very detailed data along with all this. Some time systems, Chronos and so forth, might have information that's useful for different aspects of this. And then RFID tracking for automating spaghetti mapping and things like that can also be very helpful. And so there are a lot of different data sources that are out there, and it's really just doing that inventory to recognize what you have in place and what pieces of information those different systems can contribute to the process that will help you with this. Just from a quality perspective, looking at producing a quality filter map and so forth. When you start doing the data collection, chances are you have a lot of different systems that collect quality data today. Certainly, some of the things that you would expect, such as SPC systems, work order systems in terms of non-conforming materials and so forth. There's just a ton of different systems where you have that information entered in. But then if you have additional systems such as IoT and so forth, that may be additional systems. Usually what we have found as we've worked with customers is that they have much more information available in different systems that already exist than the level of detail that they would normally put together for a QFD or quality filter map, I should say. So working with a firearms manufacturer that asked us to create a quality dashboard across their facilities, for 7 plants, we found 57 different systems that contained quality data. And, for them, they had no idea. It was nearly impossible for any single person at the company to know about all of those different systems, let alone use them for analysis. And so usually, as part of this process, there's an analysis process up front to figure out what data actually is available today, and then be able to map that and utilize it effectively. The next step is to focus on the type of information that we capture from the process. One key is to collect information beyond simple performance data. So instead of just looking at a metric like first pass yield, it's important to know what's driving the rejects. Without that information, you can't tell. You can tell if things are getting better or worse, but you won't know why. And so while that's not part of a traditional mapping process, as you're looking at the future state and being able to try and figuring out how you can improve things from a future state perspective, it's important to have that information to understand what are the problems today and how can they be addressed. As you go through and organize the diagnostic data, one way to do that is on a fishbone or Ishikawa diagram. It can also be done through Pareto diagrams with drill downs, tree map diagrams, many more ways. The key is that you want to have the structure defined as you capture information from the process. Then it'll be easier to perform the analysis on what you want to do later. And there are several approaches to the categorization. One is to have operators enter information when events occur on the shop floor. Another is to capture fault codes from the machines themselves. And then another way is to use machine learning capabilities to automate, the categorization of those events when they occur. But one way or the other, you want to have, that categorization happening at some point. Next is, how to show the maps. And there's really 4 different options that we have here. And there's no single recommendation that I have. It depends on your situation, what you have in place already today, and really what you're trying to achieve with the process. But I'll go over some of the advantages of each one of these different approaches. One is a purpose-built lean solution. These types of systems are specifically designed for lean manufacturing analysis and have many, if not most of the mapping outputs built into the software. There are several such packages in the market. It's outside of the scope of this conversation to get into the details of one system versus another. But one of the key factors to consider when looking at those systems is how easy it is to feed the data into those solutions. If it's a manual process to load the data, that should eliminate that system from consideration. You already probably have enough systems out there. So if it does have the automatic feeds, then consider which built-in reports it contains, how flexible it will be going forward, and how well it will evolve along with the process that you want to put in place. The next option on our list is utilizing business intelligence systems such as Power BI or Tableau or Qlik. And these systems are very good at taking fragmented information from all of the different data sources that you have out there, and then consolidating that information together and providing cohesive views of that data. These systems will also provide for ongoing data collection from those different data sources. The downside with these tools is that none of them have the mapping outputs pre-configured. It has to be done as part of that initial implementation. This includes the creation of the display widgets, such as they appear in the value stream map itself. However, once that initial process has been completed, the system should be pretty easy to utilize and modify going forward. Next is IIoT platforms. And these solutions have similar advantages and disadvantages to the BI options, with a couple of key exceptions. The first is that when a data source does not exist in the BI approach, then you're kind of stuck. With the IoT platforms, if you need a piece of data that doesn't exist, IoT platforms are built specifically to go get pretty much any data that you have out on the shop floor. And so they can fill any gaps in the data collection that you do have. And in addition, the IoT system can act as a hub for data on the shop floor to collect and persist information and integrate different systems when necessary. Where IoT systems typically fall a bit short is the analysis of historical information. While it's possible to do that in those systems, that function is actually much easier in a BI system. So some of our customers have used a blended approach between those two solutions for kind of a hybrid approach. And then finally, there's custom software development, where you can basically build from scratch. And some of our customers have worked with, some of the customers that we have worked with have tremendous capabilities in their IT departments. And a few of those customers have put custom solutions in place for data collection. And in those cases, it made sense for them to continue that development to add different visualizations and workflows on top of that existing code base. So from a closing thought perspective, how do we maintain the fingerprints on the process? I don't want to go too much into detail here because I only have a couple minutes left, and I do have a question in the Q&A, but there's a great book, David Mann's book, Creating a Lean Culture, that's relevant here. He talks about maintaining people's fingerprints on the data as being critical to the success of visual controls, and it applies to value stream mapping as well. And I've touched on a lot of these topics already, but I really do believe that if you automate that data collection portion of the value stream mapping process, and a lot of the creation of the outputs themselves and so forth, then you can really have the people focus on the improvements. And by making this a part of the ongoing standard work within the organization, you can get the greater involvement, you can get that lasting ownership, you can really deepen the understanding because people are utilizing this on a daily basis and so forth. And then you get that investment and change as well. So in the Q&A, let's see, if you are starting a new value stream map, can you start with digital, or do you need to create it manually first to create a starting point? Great question. Generally, you can if you have the data available, you would be able to create it automatically from the very beginning. So if you have a fairly complete implementation of an IoT system or an MES system that's capturing the work order flow or the piece flow and looking at that data, and you're able to track whether it's a work order moving through in kind of a batch mode, or if you have serialized pieces and so forth that you're able to track from station to station, then you're able to see not only how long processing is taking at a particular step, but also how long it's taking between steps. And that will give you pretty much all the information that you need in order to automatically create that initial version of the value stream map, at least from the shop floor perspective. Usually there's some additional work that needs to be done for the additional information flows and so forth to supplement just that shop floor portion of the map. Any other questions? If you think of any in the future, please reach out to me at Tim@Visual Decisions, or you can reach me on my phone number there. Within a day or two, this presentation will be available for download, and the recording will be available on my website at visualdecisions.com. So I want to thank everybody for attending today, and talk to you next week. Thank you. Bye.